This is GATE 2016 set 2 electrical question number 40. At no load condition, a 3-phase 50 Hz lossless power transmission line has sending end and receiving end voltages of 400 and 420 kV respectively. Assuming the velocity of traveling wave to be the velocity of light, the length of the line in kilometer is being asked. For NPTEL reference, you can refer to lecture number 7, Transmission Line Modeling of the NPTEL course Power System Analysis by Professor A.K. Sinha, Department of Electrical Engineering, IIT Kharagpur. Useful data you will need in order to solve this problem is that for a two-port network shown like this is the two-port network representation of the ABCD parameter, and if this is no load condition, then IR, that is the receiving end current, is 0 because there is no load to draw the current, and this minus sign comes because in two-port network the convention is 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 like this, IR is like this, but in ABCD it is taken minus IR because loads generally draw the current, so this is in this direction, so this is minus IR. At no load condition, then IR is 0 and Vs is AVR. As you can see from this, Vs equal to AVR plus B minus BIR, IR is 0, so Vs is AVR. Now A is 1 plus Y into Z by 2. Y is the admittance, Z is the impedance of the system. For lossless line, impedance is R plus Jx, R is resistance, X is reactance, admittance Y is conductance plus susceptance, that is J times susceptance, which is G plus JB, G is the conductance, B is the susceptance. For lossless line, G is 0, R is 0. So now, since G and R become 0, JB, that is J times susceptance, is J omega C, and J times reactance is J omega L. Now the velocity of wave is given by omega by beta. Beta is the phase shift constant. Also beta times L, L is length of the line in meter, is given by root over omega square LC. Now if you put the value of beta, now if you see 1 plus Y into Z by 2 is the value of A. Now Y into Z is J square omega C into omega L by 2, because Y is J omega C, Z is J omega L for lossless line. Now Y into Z is J square omega square LC. Now omega square LC whole root over is beta L, so this is beta square L square by 2, and J square is minus 1, so this is 1 minus beta square L square by 2, that is the value of A. Now beta square L square by 2, so beta value from this is omega by V. So putting omega by V in place of beta is 1 minus omega square L square by 2 V square, where V is the velocity of wave. So the value of A in terms of length of the transmission line is 1 minus omega square L square by 2 V square. V is the velocity of the wave, which is velocity of light, as is given in the question. Now one thing to note is this formula gives the length of the line in terms of meters, but in question it is asked in kilometers, so we need to do the conversion accordingly. Now to find the value of A, we know Vs equal to AVR. Now Vs value and VR value are given as 400 and 420 kV, so 400 divided by 420 kV is the value of A equal to 0.95. Now A also is equal to, as we derived, 1 minus omega square L square by 2 V square. V equal to C equal to 3 into 10 to the power 8 meter per second, velocity of light, which is same as velocity of wave. Now we know A is 0.95 and this is equal to 1 minus omega square. Omega is equal to power frequency 2 pi 50 whole square into length of transmission line, which we need to determine, divided by 2 times V square. V is 3 into 10 to the power 8 whole square. So L equal to, if we solve, we are getting 294.8 kilometer. We get L in meter and then convert to kilometer, we will get 294.8 kilometer. So this is the answer. So answer is 294.8 kilometers. Thank you.